We're going to get started. We have Dwayne McDaniel, who is presenting a talk titled Who Goes There? Actively Detecting Intruders with Cyber Detection Tools. Please give him a warm welcome.
Hey, everybody. Thanks for coming to my talk. If you're going to have hallway track, hallways out that way. Welcome everybody else in. I knew there was a line in the bathroom, so I'll stall for just a couple seconds while we get settled. But if you want these slides, and I highly recommend you get them, I made a tiny URL for you. I'm not sponsored by tinyURL at all, but I do love them as a service. Forever URLs, just because. I mean, they are trying to sell me something else all the time, but I love them. And you can customize your URL. Again, I'm not selling them. So pardon me real quick, I need to go deploy something. I know that's a little bit odd at the beginning, but I'm going to hard code some access keys there for AWS and commit this to this repo, make a nice little update message. And that should be live right now. So if I go back into main TF in this project. Yep, there they are. All right, let's see what happens. We'll come back to that. I'm Dwayne. I came out here from Chicago. I love this area. I love Colorado a lot. This was number 3 on my places to move list behind Chicago and Baltimore of all places. But like I almost moved to Denver. I got like this close. So hit me up on the internet about anything, but check out the security repo podcast as well. Jason is a guest. We're gonna have another episode with him coming out next month. So very excited about that. And anything else you want to talk about? I love talking about karaoke and rock and roll. If you know any local bands that are playing tonight, let me know. I work for a company called Get Guardian. If you didn't get a sticker, there are stickers in the room and I have more in my bag. Happy to give you some. We do this stuff as a company. honeytokens is going to come into play and some of our research that we do, but I'm happy to talk to you about any and all of that stuff as well out in the hallway. We're not sponsoring this event, unfortunately, but still would be happy to talk to you about. Okay, the crux of this whole conversation is that we know what attackers want. We know how attackers behave. And just what does that look like in real life? What is the actual implications of this? Well, I'm going to tell a couple horror stories, and I always like to preface that with, hey, these are stories, these companies still all exist. People might have got fired over it, but overall, these aren't that terrifying. And if you are terrified, just recite the Bene Gesserit Litany Against Fear, and you'll be fine. If you want to talk about Dune later, I'm a huge Dune nerd. So Cloudflare Okta, maybe you heard about this one. I think everyone on Earth got hit by this eventually down the road. There was this nation state actor who used the Lapsus playbook, we think, to get into Okta, stole a bunch of HAR files. HAR files are the uploaded actual credentials you give to Okta to like, here's my credentials. It's one of the ways you can do things. Anyway, steals those. Okta does the right thing, discloses and tells everyone, hey, you need to rotate all your credentials you got with us ASAP. And everybody thought they did. Cloudflare, to their credit, I love Cloudflare. I use them for all my personal websites. They're just an awesome front layer. They do a bunch of cool stuff. They thought they handled it. They thought they rotated everything. And then it turns out they didn't. A month after the Okta breach, in November last year, all of a sudden their Jira, their Bitbucket, and Confluence got infiltrated by these same actors. And that's bad for a lot of reasons, because people tend to hard code credentials like we'll talk about later. And basically, at the end of the day, Cloudflare says, we got this. We rotated all 5,000 of our keys. That sounds like a fun day at work. Circle CI. Maybe you got hit by this at the beginning of last year, woke up right after New Year's and found, hey, all my builds broke. Why are all my pipelines down? Why can't anything run? Well, because a developer was running Plex on a personal machine that he was also doing work on, never patched that Plex server. Through a Discord thing, people did spray attacks against Plex servers, found, hey, this person actually works for Okta and I can steal all their credentials from the browser. Oh, I can get into Circle CI now, or no, not Circle, Okta. Again, this person works for Circle CI. I can get into Circle CI now. Hey, I can start stealing credentials. Hey, I now can get into all of these customer accounts and I can start stealing their credentials. The same day they announced this, that they were infiltrated and that they had to, the only thing they could really do is rotate all of their internal credentials and tell all their customers, hey, you probably should rotate all your credentials now that are involved with us anyway. They apologized. They did the best. But the same day that they announced that, an independent researcher out on Twitter said, hey, all my Circle CI honey tokens went off. Something's going on. What? Anybody know about this? And then like 2 hours later, the news drops. Toyota. This is a really interesting story. Not picking on Toyota or T-Connect. T-Connect itself is a really cool technology. I love Toyota's cars. But they hired a subcontractor to take care of maintenance on this repository at some point in the past. For some reason, that developer pushes part of the repo into another differently named repo out onto GitHub in public. And unfortunately contained a real data server key that had 296,000 rows of customer data. On the Japanese website, they apologized about this. But it took them 5 years to figure this out, and an independent researcher finding this repo out there and saying, hey, Toyota, do you know this is here and I can see your real customer data? And they were horrified, and they rotated it, of course. And that's the story. I read a lot of reports and a lot of information, a lot of news, Bleeping Computer, dark reading every day, and then all the new reports, DBIR, Datadog's Data DevOps report, all these things. And huge shout out credit to Jason's Arcanum security bot, because last night in my hotel room, I started throwing it all these reports that I haven't quite made it through, because they're 100-page reports. I didn't get that much kind of time. And said, hey, summarize this for me. Give me top 10 lists. Just build me top 10 list after top 10 list of what was the learnings of this. And these two jumped out at me in a major way. Datadog said the problem, one of the major things is that we're still, 63% are still relying on long-lived credentials. By long-lived, we're talking like a year or more. I pulled the room. How long do you think a credential should live? What's like the longest? 15 minutes. That's a little shorter than I would say. But the reality is, I think if you talk to people like Veritas, not Veritas, Venafi, people like CyberArk, it should live for the life of the workload, and that's it. And then it should just vanish, and that should never be a good credential again. Unfortunately, that's not the state of the world we live in quite yet. I think we'll get there. But then the bottom one, code review limitations. This fits hand in hand with some reporting or some investigation we did at GitGuardian. We asked 507 IT professionals, decision makers, what are you doing about the problem, secret sprawl? 27% said, oh, we're doing manual code reviews to deal with that. Which leads to some other interesting data later. But we're playing this cat and mouse game constantly. We're constantly having to rethink the way we do authentication, the way we do authorization, the way we do all of these things, because attackers keep figuring out new ways in, except they're not new ways in. They've been behaving the same way for a couple generations now. And so it's so predictable, we wrote this down. And this is the minor, or the very, very condensed, superest high level of it. But we know that they behave like this because they keep doing this. And there are new playbooks that come out. So like I mentioned Lapsus earlier, like new phishing attacks and new ways to do social engineering. Again, thanks to the world of AI. But we pretty much follow the same pattern. Let's get in somehow. That's escalate privilege, that's steal credentials to move around laterally and then exfiltrate all the data and sell it back to you. So really, we're talking about this part, but really I should expand that over to the initial access as well. But for the scope of what I'm talking about with cyber deception, this is the box where we get them. Once they're in, we need to distract them to do something else and then kick them out of the system. Because attackers, they want these things. Yeah, you can tie down and spend your time literally securing everything in your entire organization to nth degree, but really follow the path of what they're actually looking for. Data, machine resources, anything that leads to those. And that's the pattern we keep seeing over and over and over again. Anybody know why they want your data? Starts with an R? Ransomware, yay! Or boo, depending on which side of the fence you're on that. Yeah, they want to sell you your data back. They want to sell you your data to anyone else that will buy it on the market. And they want your machine resources. Why? Mine, well, not just Bitcoin, all the other coin, Monero and whatnot, but to mine that and to sell it. How many people have ever bought machine time on the dark web? Yeah, I know this guy was going to raise his hand. Did you pay full price? No, you pay a super discounted price because you're buying stolen goods. and people making hundreds of thousands of dollars a day doing this stolen good acquisition. So we want your machine resources to either use it themselves, and want your data to sell it. So how bad is this problem? Okay, what gets you into this stuff? Sorry, I skipped a step. What gets you into this stuff? Well, that's where credentials come in. If you can find their credentials just laying around, it's really easy to just get in that database. It's really easy just to get to that data source, get to those files. How do you access a machine? You use the token to get into the machine, and there you go. So how bad is that problem, that persistent problem of hard-coded credentials just laying around? Well, we look at this problem at GitGuardian. It's one of the things we do. We look at, I think last year the average was 113 commits per second that hit GitHub public. We look at every single event. There's in fact a fun feed you can look at called, well, api.github.com/events. Don't try to keep up. It is ridiculously fast. And we only care about the commits that happen, things that hit GitHub public, and the is public event, which is something was private, now it's public. That accounts for about 17 to 20% of all the secrets we find. So anybody here has not, raise your hand if you've not read this report. Okay, just the people that raised their hand, just throw out some numbers, just yell them out. We'll do Price is Right rules. How many credentials do you think we found just last year in public? How many? Hundreds of thousands? I don't think millions would be an answer they'd accept on the Price is Right, but for sake of time, we're going to give it to you. I'll give you a prize later. It's this many. It's 12.778 million we found just in public just last year. Yeah, they're not all unique, only 3.6 million. And yeah, they're not all valid. There's a shocking number of valid. I don't have that number on here. An interesting fact, we throw out a pro bono alert every time we think it's a real person who made the commit. It wasn't just a bot on GitHub or something. So that was like 1.8 million pro bono emails we sent out last year that actually got delivered. So if you're working with Git, make sure you're using an email that's reachable. It doesn't need to be your work email. It could be any email you want, but make sure you can at least get alerts to it, because there are people in the world trying to do good and trying to tell you, hey, this commit contains dangerous things. You should probably fix it. And if we can't reach you, we can't reach you. Anyway, this is a growing problem, not a shrinking problem. These are numbers from previous reports, 10 million the year before. Not cumulative. This isn't like we keep finding and adding to the stack. We have documented over, fingerprinted over, well over 20 million hard-coded credentials out on GitHub. Fingerprinting, we take a hash of it, then we take a fingerprint of it. The fingerprint doesn't go to anything, but we can identify everything else off that fingerprint. That's a lot. That's a lot. And it's a growing problem, not a shrinking problem. Well, that sets the stage. Why am I saying all these random facts to you about how many secrets are out there in public and why attackers' path matters? Like, since we know the attack path and we know what they're actually going to be looking for, we know exactly what they're gonna do. There are very few attackers out there who are completely making it up as they go along from first principles. Those people exist. I'm sure they do. But that's not who we're reading about. Most of the attacks that we're reading about are people that are following a playbook. They're following something they downloaded. Here's a script, run it 1, 2, 3. And if you don't get money at step 3, find a new target and go 1, 2, 3. So our goal really needs to be to waste their time on stuff they can't actually use, that gives you alerts that they're trying this stuff, so you can react in a quick way. That's the whole idea of cyber deception. This is not a new idea. In fact, I would argue we've been doing this for thousands of years at this point. Sure, maybe the cyber part's out of here, but at the time, that horse is pretty cool technology. You gotta remember, all cyber is just a fancier way of saying advanced technology. Yeah, we still live with this problem today. How many people have ever been infected with a Trojan virus on any machine they've ever had in their entire life? Some people never ran Kazaa, I guess, or LimeWire. Everyone else, we had this problem. I blew up a machine once. The first time I ever had to reinstall Windows scared the heck out of me. Then it was fun. But yeah, we've been doing this. So giving something that they weren't expecting in a package where they thought it was something else. Well, this has been used against us, but we know how this methodology works. In fact, I just read a report using AI, they've been able to like recover $300 million. This was in Bleeping Computer this week, in stolen funds because they found the bank accounts where all of these funds were going to because they strung the attacker along enough with AI bots to eventually reveal enough revealing data that they could actually act on it. It was a really cool story in Bleeping Computer earlier this week. This is the, I think, Karate Kid Part 2 strategy. They can think your shoulder's out of joint, and when in reality it's not, you can swing up and knock them out. Maybe that was one of the Rockies. Anyway, basically the same film. Appear weak where you're strong and strong where you're weak. Sun Tzu said it. We don't know if Sun Tzu was real. We don't know if Sun Tzu actually wrote it down or said it, but there's this book that says he did, so we'll just say it's true. But it's a good technique. Look over here. Meanwhile, we're going to hit you from the other side. In fact, this is such a good strategy. We did it in World War II. Everybody know this story? Anybody not know this story? So I love this story. It's one of my favorite stories out of World War II. I'm not a huge war historian person, but in 1942, the US mobilizes and we're getting involved in World War II. We don't have enough tanks and bombs and planes yet. Those take a while to build. They just do. So we went to Hollywood and said, hey, Hollywood, can you help us with this? Can we do something together? We're like, well, we can build you things that look like tanks and planes, and we have sound stages. We can make you any sound you want. And they said, cool, let's do that. And that's how we got into North Africa. We shipped a bunch of balloons over, and from a distance, they look good enough, just enough to confuse Rommel and his people, and said, okay, well, let's go defend where they're landing all this stuff. Meanwhile, we snuck all the real stuff into another part of Africa and took it over. It's also happened on D-Day. There's a bunch of a balloon battalion, I think is what they're called. There's a whole documentary about this. Just look up Ghost Army. Wonderful documentaries out there in the world, including one made by the World War II Museum down in New Orleans. Then we get to this turning point in history. I am not a huge believer in the great man theory of history. I think it's accumulation of a lot of pieces, make these connections at certain times in history. But this is one of those we can point to and it's like, yeah, this is where the term honeypot actually comes from. I'm rereading Cuckoo's Egg right now. It's a great read, but if you don't have time to read a book, one, make time, but two, there is a beautiful Nova documentary from 1990 called The KGB, The Computer and Me. That's a screenshot from the YouTube. It's free on YouTube, and it stars the actual people who were involved in it. Like, that's actually Clifford Stoll. Story goes like this. He gets hired as a lab technician, as an unemployed astronomer in Berkeley. His second day on the job, there's like, hey, these computers cost $300 an hour to rent. 75 cents is missing and unaccounted for. Figure that out. So he calls the FBI. Someone's stolen our money. The FBI hangs up on him because it's like 75 cents? You're wasting everyone's time. Then he realizes through a bunch of research, and it's a really interesting story. I'm not going to get into the meat of it, but or all the details, but realizes that this person's also getting into military installations, like where nuclear weapons are. And the Air Force is like, hey, this is actually a problem. The NSA is like, this is a real problem. CIA is like, yeah, we should probably do something about this. But the problem is they can't keep the attacker on the phone long enough to trace them all the way back to where they're going through a million hops to do this. And it comes down to this telephone exchange in West Germany in 1985. It's so old of an operation that the only way to tell if someone's on the line is to go through with an oscilloscope and literally test every connection in the room. So how do they get someone to stay on the line? Well, his girlfriend Martha said just put a bunch of fake data on a server. Like, he doesn't know it's fake, and we're talking 1200 speed, 1200 baud modems. It's about 120 characters a second. Just flood it with fake information. And it was Project Showerhead, because he thought of it in the shower, like how he's actually going to pull it off. Pull scripts, conspiracy theories, like just copy paste entire BBSs into these well-named folders, and they just wait. And sure enough, they were able to track this guy back, West Germany. Turns out he'd been selling secrets to the KGB. Only got 2 years in prison for it, but there's another player in it that ended up burning to death and then driving himself back to town under suspicious circumstances. It's a really interesting story. But heart of it, what he called this problem, or what he called this solution, was a honeypot, because it's sticky. It's something that you want, we think it's in there, then like Winnie the Pooh, you get your head stuck in the honey jar, honeypot. Well, this idea spreads. It's not just, hey, this is one really cool use case. Other people are like, well, people are attacking our networks. Maybe we should do something about it. And this guy named Fred Cohen writes down the detection, or cyber deception, or just at the time, the deception toolkit, honeypots to TTK. It's very technical. I would not recommend reading this on a day where you're looking for light reading, but it's fascinating. It basically says and it's kind of overboard in my opinion, let's turn every system that's not currently in use into a trap. And you can do this. You can still figure out how to implement this framework today. But fast forward a few years, there's a guy named Alfred Yeager comes along and creates this thing called Ballista. Ballista gets bought, turns into CyberCop Sting. Shout out to Jeff Mann, who was the one that told me about Ballista in the first place because I had never heard of it before. He gave a talk at ShowMeCon and AltSecCon this year, Atlantic Security Conference. But anyway, Alfred Yeager says this phrase at one point in his career related to CyberCop Sting. And I think it's one of those other moments where we can point to in the history of computer science and say, yeah, this is kind of that turning point. It's no longer hackers who are used to be phone freaks who were just looking for free long distance so they could connect to other computers, or MIT kids who rebuilt cars on top of roofs or hooked a fire hydrant up to a drinking fountain, which you can actually go see. It's still on the MIT campus. Not the car, but the fire hydrant. But hacking was this idea of like, let's do something mischievous and fun and learning. Let's take it apart, put it back together, see how it worked. And this is kind of the era where it's like, there always were the bad element, but now hacking takes on the connotation of, these are people that are financially motivated. These are crimes that are happening. So CyberCop Sting makes a lot of sense to call it that. Fast forward a little bit, and we get to Augusto. Honeypots have not gone away. They're only getting more popular. There are all sorts of message boards out there and all sorts of email threads going on about this that are all archived. And he says one day, is like, well, honey tokens are a little heavy. Basically, what if we just had this piece of information that shouldn't flow? I've been calling these honey tokens. And this whole subdivision of honeypots is born. If anybody knows Augusto, let me know. I would love to meet this guy. He lives in Canada. But that sets off this entire other field of thinking about honeypot, or honeypot and honey token in parallel. Honey tokens, I think, get the modern definition of like how I think most people interpret honey token really comes from the way Thinkst does it inside of Canary token. Canary tokens are literally, here's a little piece of information that shouldn't be touched. In 2015, they created the open source repo for their product. And in 2016, Nick added, here are how you do AWS tokens with our system. So now for the first time, we've created a fake credential, what I think of as a honey token, and the way most people think of them, I talk to today think of them, a fake token for a system that if I try to use it, it sets off alarm bells and doesn't give me access. Then we go to last year at RSA. I missed Kevin Mandia this year, but last year I only went and saw him, honestly, if I'm being real, because Eric Idle was right after him and I wanted to get a good seat for Eric Idle from Mining Python. I just saw John Cleese this week as well, so now I'm like one left to see that's still alive. Honey tokens are your early warning signs. He says this from stage. And I happen to snap this picture and that's what it says right at the very bottom there. Honey tokens account bait. Which I think dials it back a little bit to the earlier of like just something that shouldn't flow, not just these tokens. But now we're starting to get philosophical. So what is a honey token? Well, we just walked through how we got here, and so that piece of data that shouldn't flow. But what does it mean in the modern blue team, the modern enterprise? Hey, Guardian, we said this. We had to write something down, and this is what we wrote down. Honey tokens are decoy credentials that don't allow access to any resources. Instead, they trigger alerts that reveal the IP address of the user who attempted to use the honey token. That's at a minimum. And then honey tokens look identical to real credentials. That's super important. There's a couple points in history where they didn't, and then it was very obvious, and then nobody fell for it, and then it didn't work. But on to how to build these things. This is the most technical diagram I have in the whole thing, but this is GG Canary, our open source tool to build honey tokens. It uses Terraform and AWS because what you build is a real AWS token for an account that has 0 privileges whatsoever. If you go to deploy this, I would recommend spinning up a new AWS account just for these things, just in case, because they don't go to anything. There's no credit card attached. There's nothing they can do, even if they do get their hands on these things. And then let's store that list of users in a list and go build a little Lambda function. And all it does is look for this S3 bucket that how Cloudflare will dump into anytime someone tries to use one of those credentials. Jiggles the bucket, tells the Lambda function, hey, time to send an email or an alert, somehow a webhook, something out to the public. Out of the box, you can do Slack, AWS, SES, and SendGrid. Your mileage may vary. It's open source. It's 2 years old, and we have not updated it since. So warning, but it gives you the basic idea of how to build all of this stuff. And all of this source code is open sourced. I really want to stress, though, that this is one interpretation of this idea. This is one way to go about it. It's the one that I'm going to lean into for the rest of this talk, for the most part, but I think it's important to keep that in mind for this next section. Because you can go build these yourself, or you can just get them off the shelf if you want to go deploy these. There's a lot of good reasons to deploy them, which I'll go through later. But the first is that the DIY, you can just go build this on first principles. But you can also do other thing off that first principle idea of data that shouldn't move. Why not have a passwords.txt that has a file watcher on it that if anyone ever opens that file that's full of garbage, you get to know their IP address and other information about them. That's technically a honey token. What about fake email accounts? As Mandy has said, account bait. Just fake email accounts that if anybody ever messages that account, something's gone wrong. Or somebody ever tries to access that account, something's gone horribly wrong. You can hide honey tokens inside of those accounts. It's honey tokens all the way down at some points. But get back on track to build this idea of a fake AWS token or similar system token that is real but doesn't give any access but gives alarm bells. Well, you can do GG Canary, like I talked about. Space Siren, huge shout out to them. This talk wouldn't exist without this project. Space Siren is the what was they called? The descendant of a project from Bitbucket called Space Crab, which no longer is maintained. But Space Crab, which is the coolest name, is basically how to build AWS tokens on AWS accounts, like the same way we do with GG Canary. There was a problem with their original way they did it with enumeration. It was pretty easy to tell if it was a honey token or not based on public information. And that's why Bitbucket's like, we're just not going to deal with this anymore. And then Space Siren came along and said, yeah, we'll just do this. We'll figure it out. And they sorted it out. So great code to look through. Requires AWS know-how. And then Canary tokens itself, if you can spin up a Docker container, you can run it. The problem with all of these, like every other DIY thing in the universe that needs to perpetually keep running, if it's going to have value for you, is that you need to keep it perpetually running. And there's the overhead of that. And that's why there are commercial options, off-the-shelf options, I should say. The first, and this is where I send everybody, if you are brand new to the concept of honey token, you've never heard of this and you just want to play around with it, go to canarytokens.org for free one-off honey tokens. If you want to like throw one of these out there and just see what happens, I would start there because it's free. It's awesome. They're a really cool company. They build basically honey pot as a service is their entire business model. So it's not just honey tokens, even though they call it canary tokens. It's fake databases, fake Excel spreadsheets, fake emails, fake PDFs, anything that like sets off these alarms and say, hey, someone's tried to use this. They even introduced credit cards not too long ago. One of the newest ones they have, I don't think it's on the commercial, or I don't think it's free on the free list right now, but it's coming. It's in the Canary tools, their commercial version, is CSS tokens, which is a really cool idea. Because if someone's going to make a fake login page for you, what are they going to do? They're going to go to your real login page and scrape it and recreate that. Is everyone going to stop to think, hey, there might be a CSS token in here that if it appears anywhere else on the internet, will set off an alarm bell and let the person who created this site know that someone else has cloned this? Of course not. That's ridiculous. Who would do that? Well, Thanks thought that was a good idea. I love it. I love that idea. I just found out about that back at RSA. Anyhow, I swear I don't work for Thinkst. They have Canary tokens, Canary.tools, which is the commercial version. So if you want to scale up, you want to throw 10,000 honey tokens out into the world in various forms and shapes, they sell that. Again, really cool company out of South Africa. We have a honey token module. My boss loves me talking about this part because it fits in with the rest of our platform. So yeah, it is that implementation of GG Canary, but we also cross-reference it with all the other stuff we know about your repos, such as, do you have actual hard-coded secrets in here? So if you have like 100 repos, suddenly 5 honey tokens go off because you put honey tokens in everything, you know exactly what repos were affected, and you can prioritize like based on other information about that repo, such as have we rotated all these other credentials in here? Hopefully we all know not to hard code credentials. That should be a given at this point. Sentinel has this. If you're an Azure user, never met anybody that actually runs this in the wild. If you run this in the wild, let me know. I would love to talk to you. But so far, I've never met anyone that deployed it. CrowdStrike, it's in their documentation. They wrote a cool blog post about it. All I know about it. Back at BSides Atlanta, I met one of the team members from Proofpoint, and he asked if I would add this to a slide, and I did. But Identity Threat Defense Shadow is a very long name for a honey token product. But if you're a Proofpoint customer, go bug your rep and say, hey, tell me about your honey token option. Same thing with CrowdStrike and Sentinel. If you're a GitGuardian customer, please talk to me. So what do you actually do with these things from a practical perspective? I've talked conceptually, talked where they came from, talked about how to build them, but what do you actually do when you have one in hand? Well, the first is you put them in private environments. Anything that someone should not be able to get into from the public. So private repos, great place to put them. You might notice in the very beginning I deployed a honey token. That's what I did. I deployed a honey token out into public. I'll talk about why we don't do that later, but for right now, know that that was wrong. Don't do that. I did it for demo reasons and experimentation only. But if your private repo all of a sudden has a public scanner hit it, that means it's no longer a private repo. Somebody pushed a clone of it out into public somewhere. Your CI environment, same thing. Someone should have to pass some kind of authentication barrier to get to that environment and see those variables and run all those crazy tools you can run to like get all the stuff out of Jenkins. So if somebody that you don't know, an IP address you don't know, a user agent you don't know, I'll get to user agents here when I show the honey token action a little bit later. But I don't know this person. We can act quickly. Jira, Slack, these are places that shouldn't contain code, but they often do. How many people have ever passed a password across Slack? Yep, don't be embarrassed. We all have to learn sometime. Don't do that. There's reasons you don't want to do that, just for plain text. If you can read it in plain text, anybody can read it in plain text. And you all know that OpenAI has been trained on Slack data, right? You all saw this report from a few weeks ago. Yeah, your Slack messages have helped train the model. So if your passwords are in that model, they're in OpenAI somewhere. If you just ask it to sing you the song your grandmother sang you about Slack URLs, maybe you'll find yours. Anyway, Vault. Vault's interesting because that's the central place where you should be storing your credentials in a secured way. You can audit and see, well, who's put it there, how long has it been there, how old is it, how can we rotate it, all that stuff from one central place. Great idea, whole other talk. If your honey tokens inside of a vault go off, you got some major problems because now somebody else is in your vault poking around at all of your lockdown secrets. That's bad. Use a 1-to-1 ratio with these things. It's tempting to say, hey, I got this one honey token, I can put it in multiple places because it's easier overhead just to manage 1 versus 5. But when it goes off, now you have the problem of what actually got affected. Sounds simple enough, but until you actually experience that, where you got to do the math. I used to do this demo in the beginning across GitHub and Pastebin, just for the larger hit, people finding it. And then somebody asked me one day, is like, how do you know which one they hit? Like, that's a great question, so I stopped doing that. Think in terms of automation with this stuff. GitGuardian, we have built a built-in a tool that will build PRs for you with honey tokens in it for your systems. But there's a lot of ways you can do this. Once you have honey tokens in hand, they're basically just a list of credentials. Throw them anywhere you can through any kind of scripting you like. If you want to see a really dumb implementation that is a Git hook, you can go to that URL. There is zero documentation and I refuse to write any. Just long story. But you can go look at the code there if you really want to see. It's a good use case for OpenAI. Throw my scripts at it and ask it to tell you what it does. And maybe I should just do that. Maybe I should just finally document the dang thing. This is kind of an interesting one, but I ran into this myself personally when I was first experimenting with honey tokens. Remember, you're a defender first, unless you are law enforcement. Is anybody law enforcement here? All right, I'm not going to tell law enforcement how to do their jobs. I never, ever would do that. But if you're not law enforcement, your job should be to get them off of your network. Know where that border is. Know where your perimeter of concern is. Know where, like, once you're on someone else's server looking through their files, you're no longer defending, I don't think. There's cases where maybe that's true, but just in general, you're going to find out some really cool information. Just know that you should be kicking people out with that information, not going after them. Again, unless that's your job. This is a whole journey, like everything else in computer science. I met one person who came up to me and said, "Thank you for that slide, because I was literally ready to go deploy these on everything, and that would have been like all I focused on for the next couple of days." If you do that, you're going to burn out, you're going to forget you did it, and then you're not going to get any value from this whatsoever. Start with one repo, start with one channel, and see how it goes. Just experiment with one honey token over the next couple weeks, next month. If you put one honey token in one place per week, you'll have over 50 of them deployed at the end of the year, and you'll be that much more secure. Because what you're really buying with honey tokens, and I don't have a slide specifically on this, is you're buying time. I mean that a couple different ways. One, you are buying time to shrink your dwell time. Because if someone comes in your system and trips over a flag and says, or trips over a honey token and gives you an alert within a minute of them being in the system, well, now you know they're in the system, and the dwell time is going to be a minute versus the mean dwell time right now is like 14 days for non-ransomware and 17 days for, or no, 14 days for ransomware, 17 days for non-ransomware, according to Sophos from last year. So it might be a little shorter now, but thank you. But we're not talking years anymore. Thank goodness in the industry, it's no longer the average that you have a dwell time over 300 days, which was the case literally a decade ago. We're getting better, but still 2 weeks is a lot of time to dwell, do damage, exfiltrate versus 5 minutes. So you're buying yourself time that way. Other is, if you're tackling these larger problems of like, I know this, if anybody got their hands on this repo, we would be hosed. And we got all these things we got to fix in it. All these hard-coded credentials, all of these misconfigurations, all of this other stuff that we need to worry about. Let me just throw a honey token in there right now, up at the front, and then I know if anyone's got into it or not. Buy just a little bit of breathing room. So time to fix it while you're still being defended. Lastly, what not to do. I only have one do not, and that's don't put them in public. I know I did earlier, but the internet is constantly being scanned by good guys and by bad guys and by everyone in between. I don't know how to count AWS in the good or bad situation, so they just know that they're constantly scanning the internet. It's GitHub, GitLab, GitGuardian, tons of tools out there just constantly looking for new things to exploit. GitLab and AWS, or not GitHub, GitHub and AWS actually have a partnership. And GitHub is doing awesome work these days on keeping people from committing certain types of API keys. If it's prefixed, GitHub might be able to warn you that hey, you're trying to commit this to public. But if you push it to a private repo and then make that private repo public, it gets around that whole system. And if you're using private, it doesn't stop you. Anyway, if you put it in public though, they're going to get scanned, and that's how you know that something private has gone public. So those are the two big use cases. Someone's got into something they shouldn't have had access to, or this thing that should be private now is public, and we got to deal with that. Either situation's not good, and something you should probably be working on. So let's go see that honey token from earlier. And it has been Holy crap. It has been hit 92 times in the last 38 minutes. That's about what I expected. Where are you? Netherlands. Why are the Netherlands hitting me? From AWS. Trufflehog, expected that. That's somewhere in America. That's Git Guardian. Go all the way back to the beginning. Yep, there's the first one I expected. AWS internal. We're not showing the IP address because they use some weird IPv6 address it looks better if we just say AWS internal. But the reason they hit first is because GitHub immediately told Amazon, hey, someone put this here. Amazon immediately did something called attach user policy. The specific policy they attached is a security policy that quarantines you. So that email you got that said, hey, you did this on AWS, don't do that, we quarantined your account. Another good reason, if you're gonna go build these on your own, build them in systems outside of your normal AWS account, because these are gonna get quarantined if they get popped. You just don't wanna deal with that whole, it's connected to my main root user. See, Trufflehog's in there. Someone on Amazon using Bot03, good old Bot03. Oh yeah, so what am I looking at here? This is the Git Guardian interface for honeytokens. I would show you someone else's system, but I actually work for this company, so I get free access. That's why I'm not showing you CrowdStrikes, for instance. We're using CloudTrail, and CloudTrail can give us the IP address. We're putting the little flags beside it, some GeoIP location, and user agent and the action they called. User agent's super important because I can get a new IP address like that. I have no idea how to get a new user agent without more work. And again, attackers aren't coming in working from first principles. Some maybe advanced nation states are, maybe they're after your billions of dollars in Bitcoin you have stashed somewhere. I don't know you. But most of them are following a playbook, and as soon as they get kicked out, oh, I'm getting a new IP address. Hey, I got kicked out again. Why did I get kicked out again? Because they did the exact same thing from the exact same user agent over and over again. Sumo Logic, I think, even introduced blocking, auto blocking by user agent a couple of releases ago. Yeah, so I'm just gonna clean this up. I'm just gonna revoke this thing real quick just to stop the noise. 92 events though, that might be a record. So in conclusion, we know how they're gonna attack. It's always gonna modify somewhat here and there, but we can keep sharpening the axe. We can keep pushing back on them. And one of the easiest ways to do that is just lay some traps, since we know exactly where they're gonna swing. This is a really easy trap to lay. Either you build it yourself or you buy it, but set some false credentials out there that give you information about what they were trying to do, who they are. Go build it yourself. Again, think outside the box in terms of, I can just put this here, and if anyone ever touches it, that gives me an alert. That technically falls under the definition of honey token, data that shouldn't flow. Or just go use canarytoken.org. Can't say enough good things about them. And if you're a Guardian customer, we'd love to have that conversation with y'all on it. Lastly, again, you're a blue teamer, blue team. I'm Dwayne, I live in Chicago. Check out the Security Repo podcast. We have awesome, great guests besides Jason, Jason E. Street, other people not named Jason, Tanya Janka. That always gets a laugh. Hit me up about literally anything outside of tech. And with that, I will open it up for any questions in like last 2 minutes I got. Were there any questions? Are there? Oh, and if you did not get stickers, I have more stickers. Come up and see me.
For on-premise environments, what kind of strategies or tools can you suggest for laying these types of traps and detecting when these honey tokens get?
Well, that goes back to the architecture diagram and the idea of thinking in first principles with it. So if you have an internal, I'm assuming you've written your own API internally or have at least known systems, like they contain these kinds of strings. So that's where the idea of like setting out file watchers on a passwords.txt file, that would solve that. Because one of the first things you do of living off the land is you go look for things that like that. Go look for desktop extensions that look like they would take you to a password and whatnot. You got a comment, Jason? Or you got a question? But yeah, there's just the further thought is thinking in those terms of data that shouldn't move and setting up file watchers that will provide some kind of information about who touched that file. There are multiple systems on Windows and Linux that are pre-built to do that. I don't know if they are off the top of my head though, but I have researched that a little bit.
So is there any like kind of like just off your head kind of metrics as to how effective honey tokens are versus honey pots these days? And has anyone got into like honey processes? Because a lot of modern attackers use like living off the land techniques where they'll use window APIs or install software or anything like that.
Really interesting question. Short answer is I don't know. I don't know how most of the industry would draw that line between all three in a way that they would report on that.
Yeah.
If anybody has that data, it's thanks because they build entire honeypot systems versus honey tokens. It's not something that I have. Yeah, I simply don't know the answer to that. That's a good question though. If anybody knows, let me know afterwards. Let's go research that together. I'm going to ask your chat bot this. Let's ask it right now. All right.
Yeah, I have a question about security researchers. So when you put these honeypots, you'll get some security researchers through Bugcrowd or HackerOne. How do you deal with them? Do you have to pay bounties?
Yeah, I can answer for our specific system. It's called IP allow listing. You ask them for like, hey, what are security researchers aren't going to tell you, but as you identify them, you simply say, hey, this IP range is obviously these researchers. QA departments, we allow that and with the tagging. So like what you wouldn't see is like my home network wouldn't even pop up because it's allow listed. So if I'm testing it from home, I go through Amazon or some other machine somewhere through another network. That's how I personally do it. But yeah, you can totally account for that. How you do that inside of open source, that's going to be slightly different, but there's ways to do that. Yeah, but usually allow listings to the answer. But you'd have to know that range that they're coming from. But then again, you can tie it in with user agent. So if it's this user agent in this range, they're fine. And yeah, they will get popped occasionally from people just poking around, but then do they have a reason to poke around? If the answer is yes, then you reset the token and you go back to do your work.
This will be our last question.
I'm actually interested in kind of that middle ground between true attackers and people who genuinely have a reason internally to be poking around with that. How do you address, say, large enterprises where you have like an inner source type code base where you can say, hey, this is an education opportunity for a user? Do you have some way to say, hey, I see that Dwayne hit that honeypot or honey token, and let's talk to Dwayne about not using random credentials he finds?
Yes, that actually is one of the use cases, but how you narrow it down inside your own network, like all we can get back is what CloudTrail can give us, at least for ours. So if you can narrow it down by IP address and user agent that way, yes. But also, yeah, there should just be a larger conversation. Like, why are you trying random things you find? Again, if you're QA, if you are a security team, yeah, okay, it totally makes sense, but why is it someone internally popping this off? And then you can start that investigation. But that's, no, I really haven't had that conversation too much before about the education side of this. I think for that, just the awareness training, like this talk's available online as well, not just from BSidesBoulder. This is the most updated version, but just passing around your team, like, hey, know that we are just even telling the team, like, we put honeypots out there. Don't be trying those credentials unless you have a legit reason to do it. There's no legit reason to test a honeypot unless, again, you're testing it as a security person. But anyway,
Cool.
Hopefully that answers everybody's questions.
Thank you very much.
I'll be around. So thank you.
Let's thank the speaker.